To graph a rational function, you should follow these steps. First, factor the numerator and denominator of r of x, then find the domain. Once you factor it, you want to write r of x in the lowest terms. Third, find and plot the intercepts. Use those zeros multiplicities to help you. Fourth, find all the asymptotes and graph them, vertical and horizontal or slant. Then determine where the graph is above and below the x-axis. Sometimes you need to pay attention to that, sometimes you don't, but we'll see here. And then finally, draw your graph. So we have our rational function, r of x equals x squared plus x minus 12 divided by x plus 2. So first things first, I'm going to factor it. So the top one factors out to x plus 4, x minus 3 over x plus 2. So it's now factored. And now I'm going to find the domain. Well, the domain is just the denominator set equal to 0. So x plus 2 equals 0, which is going to give me x equals negative 2. So I know that my domain of this function is going to be from negative infinity to negative 2 union negative 2 to infinity. And since it's the lowest terms here, nothing I need to cancel out, so it's all good. And now that I know the domain, I can move on to the intercepts. So I'm going to let x equal 0 and solve for y, and let y equal 0 and solve for x. So when I plug in 0 for all my x values, I'm going to end up with y equals 4 times negative 3 times 2, because all the x just disappear. And that's going to end up giving me y equals negative 12 over 2, which is just negative 6. So it crosses the y-axis at negative 6. Now I'm going to do it again. I'm going to let y equal 0 and solve for x. And the nice thing here is when y is equal to 0, you only need to focus on the numerator. The denominator does not matter. So I'm going to have x plus 4 and x minus 3. I'm going to set each one of these individually equal to 0. So x plus 4 equals 0 and x minus 3 equals 0. And solve. So x is going to be negative 4 and x is going to equal positive 3. So I actually have two x-intercepts. So negative 4 and positive 3. So I'm going to graph these three just to get them out of the way. So negative 6, 1, 2, 3, 4, 5, 6 is here. Negative 4, 2, 3, 4 is here. And then positive 3 is here. Now I got to find the asymptotes. Well, you've already found the domain, which means, by extension, you've already found the asymptotes, at least the vertical one. Vertical asymptote is going to be x equals negative 2. So I'm going to go in there and just get x equals negative 2 drawn. So red dashed line, emphasizing that the graph cannot cross that. Now I need to find the horizontal asymptote, but if I look at my function, the top degree 2 is greater than the bottom degree 1, which means there is no horizontal asymptote. But since it's off by only 1, there actually is a slant or oblique asymptote. So I'm going to do the long division. So I'm going to have x plus 2 divided in 2, and I'm going to do the non-factored form so I can do the long division much more easily. And now I'm going to go through. So I'm going to have an x up here. So x squared plus 2x. And that's going to give me a negative x minus 12. And that'll be a negative 1 there. And honestly, from here, I don't have to go any further. This is my slant asymptote. So slant or oblique asymptote is going to be y equals x minus 1. So, graphing that, -1, and the slope is +1 right there. So I'm going to have this slant asymptote looking like this. Now, you're supposed to look to see where the graph exists above or below the x-axis. But you don't have to in this case because there's no extra gaps or extra vertical asymptotes, and there's no horizontal asymptote. So we can actually just draw the graph with the information we have here. It has to cross this point here, and it cannot cross one of my red dotted lines. So I can't come from the top. I have to come from the bottom. So where in the bottom? Not quite sure, but I'll just kind of eyeball and say it's here. And then it goes up like that. And then it has to cross these 2 points here, so it can't exist up here. So it has to come from down here. So through the point, like so. And here is the graph of this rational function with all the information we were able to get out of it.